This is an exam assignment from 2009. Here we are given the number of days per year, 250. We know the order cost, 1000, purchase cost, 651.15. We have interest rate equal to 0.3 and lead time equal to 4 days. We also know the average and standard deviation of demand per day, which is 40 and 10 units respectively. And then there are 5 questions that we will try to answer to 4 of them. Question 1, 2, 3 and 5. In the first question, we need to we will assume that the company implements a continuous review system, and for this system we need to calculate the optimal order quantity and then find a reorder point that the probability of all demand during an inventory cycle being satisfied or immediately from inventory be at least 95%. It is the definition for the service for the cycle service level. So here we have the cycle service level equal to 95% in question 1 part 2. Okay, let's start with the first question, but to do the calculations for the first question we need to know the holding cost and also the annual demand. The holding cost, if you remember previously we said that it can be considered as the opportunity cost for the investment that we have made on the items that we hold in the inventory. So the purchase cost multiplied by the interest rate will give us the inventory holding cost per unit per year. Then we have the annual demand, which is equal to the average daily demand multiplied by the number of days per year. So it is 10,000. It is in fact average yearly demand, or the average yearly demand. So next, EOQ, which is the square root of 2 times B times S divided by H. 320. It is the economic order quantity and the optimal order quantity in this case. So in the next part of question 1, we need to calculate the order point for a cycle service level equal to 95%. To do so, we need to calculate the average and standard deviation of demand during lead time. For the average, we have lead time multiplied by the average daily demand, which is 160. And then for the standard deviation of demand during lead time, we need to multiply the square root of the lead time by the standard deviation of demand per day. So it is 20. So good. Now we can calculate the safety factor. We can calculate the reorder point. To do so, we need to calculate the safety factor. Safety factor is inverse of the standard normal distribution, evaluated at point equal to the cycle service level. So it is norm S in, I will put 95% in it, so it will give me 1.645, and then a safety stock is the safety factor multiplied by standard deviation of demand during lead time, and reorder point is the average demand during lead time plus the safety stock, which is 193 here. Question 2. Now we assume that a periodic review system is implemented, and we want to first find the review period to use and then find the restocking level to obtain the same service as question 1 part 2. If you remember, we said that in our calculations for the restocking level, we assumed RP reorder period is given and is known. But here we don't know what is that. But we can do some calculations based on the EOQ formula, based on the optimal order quantity to find a good estimate for the reorder period. Here, first we'll calculate the number of periods that we have each year. So it is the demand multiplied by EOQ. So it is the number of cycles per year, and if we inverse it, it will give us the duration of each cycle in years. So 1 divided by the number of periods or cycles will give us the review period in or reorder period in years, and then I can change it to I can convert it to days, because I know each year is 250 days, so review period is 8 days, and I need to round it up in order to get the final reorder point, reorder period. So it is 8. 8 days is the review period. In other words, every 8 days I will go and check the inventory to see if it has reached the restocking level, if we need to make an order to increase the inventory level to restocking level or not. Question 2, part 2, we want to calculate the restocking level. To calculate the restocking level corresponding to a desired cycle service level, I need to calculate the demand during RP plus L. So the average would be RP plus L multiplied by average demand per day. It is here, okay, 480, and the standard deviation is square root of RP plus L multiplied by the standard deviation of demand per day. So next I need to calculate the safety factor. Norm S in 95%. Of course, I'll get the same number, the same value for the safety factor as I calculated previously. And then safety stock is the safety factor multiplied by the standard deviation during the standard deviation of demand during RP plus L. And restocking level is simply average demand during RP plus L plus safety stock. Yeah. So this is the solution to question 2. Now we want to calculate and compare the costs for the two systems in question 1 and 2. Well, let's start with the continuous review system. The ordering cost is equal to S multiplied by D over Q. The over Q will give us the number of orders, the expected number of orders made per year, and then if we multiply it by S, it will give us the ordering cost. And then for the inventory holding cost for the cycle stock, we have Q over 2 multiplied by H. So the cycle stock inventory holding cost is equal to the ordering cost. This is what we expected, of course. Then we need also calculate the holding cost for the safety stock, and it is simply the safety stock that we'll keep in our, let's say, the first model, multiplied by the unit inventory holding cost. And the total cost of the system is simply the summation of these three costs. Now let's do the calculations for the periodic review system. Okay, for the periodic review system, the ordering cost is equal to, we'll do it step by step. Here we have the reorder period equal to 8 days. So I can say that 1 over 8 will give me the number of review periods per day, right? And then if I multiply it by the number of days per year, it will give me the number of reorder periods per year. And I know that in each review period an order is made, so I need to multiply this number by the ordering cost, 1000. So it will give me the ordering cost of this system. Then for the cycle stock, in each cycle, the demand to be satisfied is equal to RP, which is 8 days multiplied by the average daily demand. So let's say it is equal to 8 days. In each day we have 40 units, so it is the average demand per cycle. This is the total demand per cycle. For this amount we need to, for this demand we need to keep the equal number in inventory, so this will give us the Q if we think as a continuous review system. So the average inventory that we have is at Q over 2, or the demand per cycle divided by 2. So I will just multiply it by 0.5 instead of that. And then for each units of this average inventory we will pay the holding cost H. So this will be our holding cost for the cycle stock. For the safety stock we have for the periodic review model, the safety stock is 57, so the holding cost for the safety stock will be 57 multiplied by H, and then the total cost is, of course, the summation of these costs. In the next part, in the next question, which is question 5, that we will answer in this video, again there are 2 parts. It says for the order quantity and the reorder point found in question 1, and by assuming that demand during the stock out periods will be backlogged, you are asked to calculate first the expected number of stock out periods per year. So the number of cycles per year is equal to demand divided by EOQ. it is 31.3. Then the cycles without any stackout are in fact the number of cycles that we have multiplied by the cycle series level, which is 95%. So 29.7 is the expected number of cycles without a stackout. Then we can calculate the expected number of cycles with a stackout, which is just a difference between these two numbers. So this is the expected number of cycles in total, and then expected number of cycles without stackouts. And if we find a difference, so 1.6 will be the expected number of cycles with a stackout. In the second part of question 5, we will calculate the expected fraction of demand that can be satisfied immediately from the inventory that is available. In other words, we want to calculate the realized fill rate for the system, for which we calculated the reordering point in question 1. Okay, this is the formula for the realized performance. So for the realized fill rate. So we know the ROP, we know the Q, and we want to find FR, and we need to use this formula. We have this formula in parts, so we need to know the Z, then we need to calculate Gn of Z, we need to know Z plus Q over sigma dL, and then calculate the Gn at this point. And then having these two values and Q from the previous previous questions, we can calculate FR. So let's start with Z. Z is if you remember, it was ROP minus average demand during lead time divided by standard deviation of demand during lead time. So it is ROP, I will go to the first question, okay, minus average demand during lead time divided by the standard deviation of demand during lead time. Then Z plus Q over sigma dL is simply Z plus Q, which is 320 over sigma dL, or standard deviation of demand during lead time. Okay, so next I need to calculate the Gn. For the Gn, if you remember, we had the formula using the density and distribution, cumulative distribution functions. Okay, so here Gn for Z would be normal distribution. We had the same formula, in fact, in the template in which we calculated the corresponding Z for a target Gn using goal sig. So you can use the same formula, you can check the formula there. So this is for value Z with mean 0, standard deviation 1, and we do not want it to be cumulative. Okay, no, we are not done yet. So this phi of Z, this is the lowercase phi of Z, minus Z multiplied by 1 minus, this is capital phi evaluated at point Z. So this is again norm dist of the, at this point, z with mean 0, standard deviation of 1, and this time we want it to be a cumulative distribution function. That's it. Okay. So I need to use this to do the same calculations for Gn of z plus q over sigma dl. And here you can see it is very small. It is 0 as it appears here. So that's why we always we said that we can approximate this formula for the realized field rate by ignoring the second expression in the numerator in this formula, because we said that for sufficiently large q's it will be very close to 0 and it can be ignored in the calculations. I put it here so you can see that it is in fact 0 here. Okay, so let's calculate the realized field rate. This is simply the formula that we have both in this cell and also here. So it is 1 minus sigma dl, standard deviation of demand during lead time, multiplied by Gn of z minus standard deviation of demand during lead time multiplied by Gn of z plus q over dl divided by q, and q is 320. So the realized field rate for the system in question 1 is equal to 99.9%.